Oh my goodness. I got lost in whatever I was looking at. I was looking at my stream info. All right, so let's see what's in our current events here. Um, I was looking at my stream info, changing it to last month because now that it is December, we have to finish this month to become completers. Okay, so let's see. Are any of these good? Musk. Oh, I did see this. I saw this. That was interesting. Should we see if there is anything about Golang? Ooh, this looks like a good one. It should suggest this. Maybe. We'll see if it's good. Oh, never mind. It's a big, long podcast, I guess. Read by Dr. One. Oh, never mind. All right, I'm not going to read it, but let's learn one thing. In fact, let's go to the very bottom. Let's see what one thing. Oh, the legacy and future. Okay, cool. Go's journey over the last 15 years has been nothing short of impressive. From its humble beginnings at Google to becoming one of the most widely adopted programming languages in cloud computing and infrastructure, Go has shown that simplicity and speed can indeed coexist. That's good, baby. That's good. Um, oh yeah, this is what I was distracted by. Um, there's a notification here, so let's have a quick look. It says, Together for Good starts today. Earn badges when you donate $5 or more using Twitch charity. Interesting. Let me put that back where it goes. All right, so, but here's the deal. Many developers in the pursuit of advanced features and flexibility have often turned to languages like Python and Java. Go, however, chose a different path. Instead of piling on features, it stripped down complexity, focusing on what matters most, building fast, reliable systems. Go's minimalist approach means that its legacy is defined by simplicity, but that doesn't mean it's stuck in the past. It's evolving, adapting to new challenges like AI and real-time infrastructure. Therefore, Go's future looks incredibly promising. With growing into... Look at the way they use all these bolds. Is that weird? Like, why are they using bolds like this? Should we learn anything else? I think that's good. So let's close this and let's close the current events. So here we are, exorcism. Let's go back here. So, there are still several that I haven't tried, but for now, I think I want to knock some out that I have tried before. So that could be Colette's conjecture in JQ. Honestly, I do think tonight would be a good night to try the JQ. Sure. Now, that's not the only JQ problem, though. There is another one, right? And, okay, let's take a quick look. So it says icon of JQ. So there are two. There are two, right? So this other one is Knapsack. So I haven't looked at Knapsack yet. The Knapsack featured languages are Java, JQ, and Prolog. So JQ and Prolog are a couple of the ones that kind of scared me off. So I think it would be good to do maybe JQ today and maybe Prolog tomorrow. Let's hop into JQ. So we are going to try copying this. Oh yes, let's open this. Okay, here we go. So we're gonna go to exorcism. We're gonna go to JQ. We're gonna go to knapsack. Okay, so what is this about? Let's look at the README. All right, so it says, welcome to Knapsack on Exorcism's JQ track. Oh yeah. If you need help running the tests or submitting your code, check out help. Okay. Introduction. Bob is a thief. After months of careful planning, he finally manages to crack the security systems of a fancy store. In front of him are many items, each with a value and weight. Bob would gladly take all the items, but his knapsack can only hold so much weight. Bob has to carefully consider which items to take so that the total value of his selection is maximized. So this is the classic knapsack problem, right? And we know that this is actually NP complete, right? The actual knapsack problem is NP complete. Oh, they even have a link. That's exactly where I was going to go. So the idea is we have all these various items with different weights and values. And there is definitely one exact answer, which is the most value that we could possibly stuff in the bag. But to discover it, so this is one of CARP's 21 NP complete problems. So it's basically hard to compute. It's hard to discover the one and only optimal solution to the knapsack problem. Let's see what it says. All right, so your task is to determine which items to take so that the total value of his selection is maximized, taking into account the knapsack's carrying capacity. Is this really the one I want to do in JQ? Oh my gosh. Okay, so for example, if we have some items and they all have their own weights and values, right? Just like we see on Wikipedia, it's the classic problem. So for the above, so the first item has weight 5 and value 10. The second has weight 4 and value 40, and so on. All right. So let's think about this. So we could take a 4 and a 6, for example. So if we took the 50 and the 40, that would be 90. So that's got to be the best, right? Okay, so it's a simple example, right? He cannot get more than 90 as his knapsack has a weight limit of 10. Okay. Bob can only take one of each item. All right, and so we're going to try to tackle this in the JQ. I mean, JQ, it's not even really, it's not usually called a programming language, is it? It's a JSON query command line tool, right? Oh, it is listed here on Wikipedia as a programming language. So here I eat my words. I was completely wrong. Okay. It says very high level. Sure, let's read the whole Wikipedia. This is going to be good. Because obviously I'm not informed on this topic. JQ is a very high level, lexically scoped, functional programming language in which every JSON value is a constant. JQ supports backtracking and managing indefinitely long streams of JSON data. Interesting. So it sounds like, so remember, on this problem, one of the other languages is Prolog. So the way they're describing it here, I feel like we're actually going to discover some similarities between JQ and Prolog. Do you think that's what's going to happen? If there are similarities between the two, I think this problem might highlight them. Okay, so let's see. Yeah, managing indefinitely long streams of JSON data. Cool. It is related to the Icon and Haskell programming languages. So it doesn't say Prolog here. It says Icon and Haskell. I'm not familiar with Icon. Let's just read this short blurb. Icon is a very high-level programming language based on the concept of goal-directed execution, in which code returns a success along with valid values, or a failure indicating that there is no valid data to return. The success and failure of a given block of code is used to direct further, so on and so forth. Okay. The language supports a namespace-based module system and has some support for closures. Okay, cool. In particular, functions and functional expressions can be used as parameters of other functions. The original implementation of JQ was in Haskell before being immediately ported to C. Okay, good to know. All right, so do we need the history? I'm going to briefly look over it. No, I think we're good. Let's look at command line usage. JQ is typically used at the command line and can be used with other command line utilities such as curl. Here's an example showing how the output of a curl command can be piped to a JQ filter to determine the category names associated with this Wikipedia page. Okay, let's give it a shot. So we're going to take this curl, right? So we're looking at the programming language. We're going to look at the format JSON, and then we're going to look for the parse, and we're going to look for the categories, and then I guess we're going to get them as an array, right? and then we're going to get whatever is in there, I guess, something like that. I certainly do not understand everything that was written there. Let's try running it. Okay, so we got articles with short description. Query languages, 2012 software. Programming languages created in 2012. Programming languages, functional languages. So we also got two description, or what is it? Two talk categories, I believe. Are they talk categories? No. What kind of categories are they? They're hidden. Hidden categories, I guess. Okay. All right, so we can do that. So we run this very short, sweet, simple JQ query, and it works great. Very cool. So that's good. Let's see. So the JQ filter shown is an abbreviation for the JQ pipeline. Okay, so it could be written in a more verbose format by saying, okay, so we're going to take this first key, and then we're going to take this second key, I guess. Okay, here, let's try this. Let's try getting this actual JSON and seeing, like, what we would do with it, right? So if we fetch this... So this is what I would typically do. I would just fetch it, then I would just get the result off of the network tab, probably. Was it this? Preview? Okay, so then I would just store that as global, typically. And so then here it is. And so then on this temp1, apparently we have a parse. No, we don't. Do we have a text? Oh. Okay, so I may be looking at the wrong thing. Let's try running the fetch again. Okay, no, it looks like the same. Oh, okay. Oh, never mind. I stored the wrong one as global variable and didn't realize it at first. Okay, so temp2. So it has a parse. Does it have anything else? No, it just has a parse, right? Okay, so we'll get the parse. All right. Then we'll, let's see what keys there are on it. So it has title, page ID. So let's start looking at some of them. Title, okay. Page ID, all right. It's a big number, I guess. Cool. Rev ID, a bigger number. Text, okay. So, how much text is that? Oh, wait a minute. So there's a star here. Why is there a star here? Is that the only key? Yeah. Okay. Interesting. Okay, so we'll get the... So now we can't go dot star, right? We have to go star like this, which is what we saw here, right? They put it in quotes. Okay. So then if we wanted to look at these keys again, so we do see that there is one for categories, right? So let's look at categories. Right? Can we see that okay? I think so. Let me close this. I don't like having that. All right, so then what's this? So we have all these categories listed. Oh, okay, so now here's something interesting, which is that we mapped this, right? So we basically did map, right? That's what we did. And then basically to make the output look more like what we got here, right? So it looks like this. Okay. So that's the same thing. So look, they have it, they used, I'm not even speaking. We used a very terse syntax. Square bracket, dot, and that's for mapping, I guess. That's very cool, right? So let's look at what it says. Both the C and the Go implementation. Okay. Wait, did they even explain? Did they even explain the mapping? No, but maybe we'll explain it later. All right. Okay, so JQ by default acts as a stream editor for JSON inputs, much like the sed utility can be thought of as a stream editor for lines of text. However, JQ has several other modes of operation. It can treat its input from one or more sources as lines of text. It can gather a stream of inputs from a specified source into a JSON array. It can parse its JSON inputs using a so-called streaming parser that produces a stream of path value arrays for all leaf paths. Okay, so I don't know about this. I'm going to skip on to this because this is going to help us, I think. This is going to help us with the problem. Every JSON value is itself a value in JQ, which accordingly has the types shown in the table below. Okay, so number. So these are like JavaScript numbers. Makes sense. Look at the way this one highlighted. Huh. We can use string. All right, we can have a hello. We can have an emoji face. That's fine. Boolean is allowed. Cool. Array. Yep, it happens in JSON quite a bit. Object. Sure. Null is also a thing. Sure. So null is a value just like any other JSON. Scalar is not a pointer or a null pointer. All right. I said scalar really weird there. I don't usually say it like that. A JSON scalar. Okay. So there are special syntactic forms for function creation, conditionals, stream reduction, and the module system. Are we going to see those in this article? I'm not sure. Looks like it's fairly short, but that's okay. Here's an example which shows how to define a named parameterized filter for formatting an integer in any base from 2 to 36 inclusive. The implementation illustrates tacit or point-free programming. Oh my goodness, okay. So, we defined something. Okay, so to base $B. All right, so if we go into here and we look at our JQ file, do we have something like that in our stub? Do they provide a stub? Usually they do, right? No. Okay, so the stub is not a lot in this one. Okay, interesting. So here we define some kind of function. Okay, cool. Digit mod. What is this? What did we do here? Did this make them into an array? Okay, so let's see what comes out. So we'll copy this, and then we're gonna echo. Let's see if I can maybe use looks like I missed something. Oops. One. There. No, 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 that's not it. We want to just JQ this, I think. Maybe? So this is a JQ. Okay, what is it gonna... Uh-oh. Uh-oh. I tried running it with this, and now it's all confusion. Uh-oh. Okay, stop, stop. Okay. Yeah, okay, that's not... You don't suppose we have a JQ REPL, do we? JQ REPL? Nope, not replace, not replace. REPL. JQ playground. Okay, so fair enough, fair enough. Huge fan of JQ. Okay. The classic send more money verbal arithmetic game. Parsing expression grammars. Okay. So, do I get what this is? So, what is this? It looks like we're trying to make something into an array or something. Let's look at this playground, sure. Okay. So, what do you think will happen if we put this here? apply. No, okay, hold on. So $B is supposed to be our input. Okay. So on knapsack, our input is supposed to be, I guess, some JSON, I guess, right? So let's look in the test file. Okay, so yeah, this is like a JSON, right? I guess. And again here. So some kind of JSON is supposed to come in. And then we're supposed to select the right items, obviously, right? I guess it's quite a few tests, huh? Okay, okay. So this one takes a maximum weight of up to 750, and there's a whole bunch of items that we could possibly take. This is going to be interesting. This is going to be interesting, I think. Okay, so JQ manual online. Yes, this is the place to be. And so when I was looking at this before, I was thinking, I'm really going to have to read this whole entire thing, huh? And honestly, yes, I might. But this one does seem possibly like it might be easier to wrap my head around than the other JQ problem. We'll see. All right, so here are a bunch of command line options, right? So let's skip over these because I don't think they're going to help me right now. Okay, so the simplest filter is just a dot, so this produces the same value as output. Okay. So we have, I'm tempted to skip down to conditionals because we're going to need to use something like a conditional, I guess. Man, I've already been at this a while. I mean, I've already been online a while and haven't really done anything. Okay, so we have an if, then, else, end type of option, I guess. So that's cool, right? Um, but I don't know if I expect us to have, like, looping in a traditional sense, right? It seems to me that we're likely going to use some form of recursion rather than looping per se. So regular expressions. Okay, so I think what we're going to do is define a function, probably. If we define a function, then we can use it recursively, I would think. Oh, these are built-in functions. Okay, so what about creating our own functions? We saw that. We, of course, saw that in the Wikipedia page, right? So recursive descent ... Wait a minute. Let's look at the Wikipedia page again now. So they used def here, right? So let's see where def is in this manual. maybe down here. Here we go. So this is under advanced features. Fair enough, fair enough. You can define, you can give a filter a name using def syntax. Okay. Okay. So on the Wikipedia page again, it shows like this is okay, so we define toBase and then we define several other named filters like this, right? So that's cool. Okay, so let's try. I'm not even sure how we're going to get started. Remove this line and implement your solution halt error. Okay. So let's try and say def. Wait a minute. And then how how is it going to be called in the test? Let's look again. It's just going to call our file, I think, right? Yeah, so it says run JQ, file is knapsack JQ. Okay, that's fine. All right. So in our knapsack file, let's define some filters. Okay, so what's the first named filter? This will be capacity, I guess. I don't know what the send more money verbal arithmetic game is. Really pretty lost as to where to even get started. Okay, oh, here, let's try this. Here's something that might help. Let's try putting one of the test inputs into that playground, right? So let's start at the top, and let's do this one. Okay, let's start with this first one. So here, there are no items, so we have to get 0, right? Okay, so the playground is here. Okay, so this is the input. Okay, and now we're going to try to get items. Okay, so then we hit apply. And so we got this. And now, so because there are no items, then we can't get any number. And we know we have addition that we can do. We're going to need to add up the numbers of values, I guess. Oh, man. You don't suppose we're not going to try to, like, take the maximum out of every, like, possible solution. Honestly, yeah, the problem is that there are just so many possible solutions. But in this case, so, ask it, I want to do that. Okay, so here's another case. So we could probably just put these different cases in here, right? So now we can't do items. Can we do, what does this do for us? So how did the mapping look? There was some mapping that we saw, right? In the first example. Oh, okay. Is that it? No, it was... What? Okay, so we turn. Oh yeah, yeah. Oh, okay, yes, yes. That did do it. It looks like. So, um, so we got that. So then we can probably add up like all of the values, right? So I guess is there a sum or something like that? There's probably something. It can be add. Okay. So now if we're in here, so now we've done this, and now we want value. What's that going to give us? Null. What's that going to give us? Okay. So then we add, as in this example. So do we put add last? Cannot iterate over number 1. Okay, so we don't want to do that. We want it to be like in an array, I think, right? So can we do that? Like, does that make any sense? Okay, so now I guess we can add that. All right, so now let's add another input. So it added up each one, so we don't want that. If we don't add, then yeah, of course they each get put into their own array. I don't think we can do that across pipe, can we? Oh, we can. Okay, great, cool. Great. Okay, so now we can add. Yeah, okay, so we added up 41. Okay. All right, so now Now, the null here should end up being a 0. This 1 should actually be a 0 because we can't take the item with the weight too high. And then here, again, it shouldn't be 41, it should be 21. Because the 21 has the highest value. Okay. I think this is getting close. I like this free online JQ playground, I think. It's certainly helping me out a lot with this. Okay. So, all right, so let's not add. So we want, I think we want to show like the weight in some way. Or we want to do a comparison on the weight with the maximum. So let's look at the comparison here in the manual. Conditional and comparison. Okay. So we're going to say, let's take the item, or we'll take the set of items if the weight is less than maximum weight, and otherwise not. So one thing we could try is, shoot. We're going to have to try a few things. Okay. I don't think I'm going to get much of anywhere with this tonight. Okay, so now we have weight and value. I feel like we are going to take, like, permutations or something. No. Yeah, once again, I think if I were to read this whole manual, I would find a hint about what it is that we think is going to work. Okay. What was the other one? It was Java. Okay, so Java JQ prologue. So on the other prologue one, I started to do it in Python and then realized that I had done it badly from like the start. For these backtracking ones, I haven't really practiced backtracking. Honestly, I haven't really practiced backtracking ever. I am going to move on to something completely different right now to contemplate how I am going to do the backtracking. Robot simulator in Python should be very easy. I have 18 minutes before I want to log off. This one should be one that I can knock out. And I feel like I do want to knock one out, so let's just knock one out. I'm going to have to contemplate how we're going to do like the backtracking and everything. I'm going to just sit at some point and just work it out on paper. Okay, so test. Okay, so coordinates. So we're supposed to have, okay, so coordinates on there. Okay, so class robot, self coordinates equals x pause, y pause. Has no attribute move. Def move. Self, okay, what gets passed in when we move? It just passes in a letter, it looks like, or I think a sequence of letters eventually, but sure, let's just call it a letter to start with. Globals for the directions, change the values as you see fit. Okay. So I guess east is 0, 1. West is 0, -1. North is 1, 0. South is -1, 0. Something like that. So then when we get the move, what letters were we seeing in there? R for right, L for left. Okay, so it needs a heading, I guess. And I think it says in the README what the heading is supposed to be to start with. It says we should, I think it's north to start with. Oh no, it gets passed in. Oh, okay, so direction gets passed in by default is north. Okay, so self.heading equals direction. Okay, so then move. Okay, so then we'll match. I don't use the match in Python much. Let me look at that. Python match. Okay, so we're going to match. So we're going to go through everything in there, right? So if I have a string, a equals a, and then for c in a, print c, and then if I have a equals, and then I do the same, then they all come out, right? So we're going to go for direction in directions, and then we're going to match direction, right? So then it'll be case L, and then we have to increment our self.heading, right? Okay, so let's do def inc heading self, and we'll say self.heading equals, and we'll say no, I guess it's more, let's just call it turn left. That makes more sense, right? So if we're turning left, then self.heading equals and the match is a statement, not an expression, right? Okay, so self heading equals, so if we were heading east, we're gonna go south. I think I did that wrong. Turn left, it's north. Oh my gosh, okay. Case north. I feel like I used to be smarter about some things. If I were going to spend more time on these, I think I would figure out much more elegant or something ways to do some of this. Okay, do we need breaks on these? So these did returns. These did prints. Superficially similar to switch, more similar to pattern matching in languages like Rust or Haskell. Only the first pattern that matches gets executed. Okay, so there's no fall through or anything like that, right? Okay, so we should be good there. All right, so case R, self turn right. Okay, so then what other letter? I think there's just one other letter possible, I believe. Let's look again. Okay, so we have R, 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 L, L, A, and I think A is the only other one. So I think we're nearly done. And how much? Yep, yep. Okay, so we'll go case A, self dot advance. Okay, so then when we advance, let's see, I don't suppose we can like add a tuple, right? So like 0, 1 plus 0, 0, 1. No, there's nothing like that, right? They just get concatenated together, right? So we want to, okay, let's exit. And then, so now we're going to say self coordinates sub 0 plus equals self heading sub 0 and self coordinates sub 1 plus equals self heading sub 1, right? So let's see what that means. So if I start at 0, 0 and I'm heading north and I advance, then I get to 1, 0. Okay, so that's probably not what it should be because that's the x direction, right? Okay. So if we're doing that, then we're going this way, so that should be east. Okay. This should be north if we're going up in the y direction. I didn't even bother to look at which was x and y. I just put numbers on them. I mean, that's it. Let's test. Okay, I have... Oh. Name capture east makes remaining patterns unreachable. Okay. This definitely isn't what I wanted. And it makes me think we should refactor. This is not readable at all. I actually kind of hate it. Direction. Oh, I put heading. Okay, so wherever I have heading, I guess it needs to be direction. Let's submit. And how much time have I allowed myself? I'm not going to try anything else. I'm just going to try and refactor this. Let's see if the submission is accepted. And I'll take 5 minutes and try for a refactor. It just says passed. The robot didn't give any notes. Okay, so let's look in here. How do we want to refactor? There's so much refactoring needed. So we don't need this. That's not good. Okay, so north, east, southwest. Can it be an enum? So, yeah, right? Okay, let's try and see if we can do from enum import enum. All right. Class direction. And we put enum in here, right? Okay. Okay, so now instead of this, can we put direction north? Right? So wherever we have this, do we want it to put direction north. If I want to just, if I don't want to put direction dot north, and I mean I can, but can we actually just put north, or even just north equals direction north? I should be careful here. Okay, so no, that won't work because it's expecting those values when it passes something in, right? Okay, let's go back a little bit. So that's not it at all. It was starting with east, and then this was north. Yeah. Okay, so I think we can maybe use it, but this becomes direction right? Direction object is not subscriptable. Oh, wait. Oh, so, oh, that's here. I don't think that's gonna work. Let's see. Oh, wait, so, oh, we have to do the value if we do that. So that's here. Can we do that? No, we failed 8. Okay, so I think I messed some of these up. So turn left. If it's east, then we turn north. North to the east to the north, north to the west, west to the south, south to the east. I would think maybe that would be okay. So self-direction. Okay, so then let's do these. That's a pretty, I'm pretty satisfied with that refactor. I like that actually a lot better. So I'm gonna submit that second solution. And now I'm already pretty much at the time that I wanted to stop. I'm just going to look one more time. Okay, so I actually do like that quite a bit better. Um, so I guess what I'm wondering is whether turn left and turn right, like, this seems redundant in some way. And so I wonder if some of this could be refactored. Um, let's hit it with black. Okay, that's nice. I'm very satisfied with that first refactor, and I would like I'm on the fence about whether I'd like another one, but I'm gonna call it good. Let's submit that last example. And let's see if it gets accepted over here. And then that's gonna be it for the night. All right, so yeah, let's see. I think it's fine. I'm gonna go ahead and mark as complete. At some point, so for some reason, I decided before I even started working on the 48 and 24 that I was not going to look at community solutions during the challenge, because it is a challenge, right? Like, I think it's, yeah, it's marked as challenges. Actually, I wonder if there's anything else under challenges. I don't know. .404, okay. But it's marked as a challenge. So challenge to me means, hey, you know, test yourself, right? So that's kind of what I'm doing. But I think it would be extremely valuable to look at the community solutions. I actually did look at the community solutions for one of the Elixir ones. It was this one. And I was very happy with what they did because my solution here is crazy huge. And it does not need to be like this. So like I literally in here I go through and I like spawn different processes somewhere. Like I spawn this process and then I like wait for it to send me a message basically somewhere. Um, yeah, listen. So we listen for something to come in, I guess. Uh, oh no, receive, do, message, merge maps. So it's crazy and it doesn't need to be this way. We can instead use Elixir task async, I think. And if I look in the community solutions, I'll see it. But they literally do this, and it makes all of that unnecessary. So I was glad that I looked at that. And so after I complete the challenge, I want to complete the challenge without looking at community solutions. But after I complete the challenge, I will look at community solutions to my heart's content. But yeah, so we marked the robot simulator. It'll probably be just about as easy in Gleam as it was in Python, I guess. But yeah, like Knapsack is a backtracking one. Zebra Puzzle is a backtracking one. They both make use of Prolog.